In this video, we're going to go over a problem involving a titrated medication, but before we do, let's go over a couple of points. Okay, so medications that are titrated have an initial dose, an incremental dose, and a maximum dose. So the goal for this type of problem is to construct a titration table that will tell us how to adjust the flow rate of the IV so that the patient receives the drug at the indicated rate until the desired response is achieved. Okay, so the desired response depends on the medication being given to the patient and the patient's condition. So for example, a desired response might be a reduction in the patient's pain, or in the case of a pregnancy, right, the desired response might be to induce labor. Okay, so I encourage you to read the information in the book about titrated medications, and they do an example of how to construct a titration table. Okay, so I encourage you to view that information. So the problem we're going to do is like example 11.19. Okay, since the examples are already worked out in the book, okay, what I did was I copied the information, and then I changed some of the numbers. So the numbers that I changed here are in bold. Okay, so the problem is, right, to induce labor, okay, the order is pitocin, okay, which is oxytocin. Okay, start at 2 milliunits per minute. So MU is the abbreviation for milliunits. So pitocin, okay, start at 2 milliunits per minute IV. Okay, and we may increase that by 1.5 milliunits per minute every 15 minutes to a maximum of 8 milliunits per minute. Okay, and then it says the strength of the solution in the IV is 20 milliunits per milliliter. Okay, so there's a lot going on in this problem, so let's try to break it down. Okay, so remember what I said earlier, right? There's an initial dose, okay, an incremental dose, and then a maximum dose. Okay, so the initial dose that the patient is receiving is 2 milliunits per minute. Okay, and the patient is receiving this medication through an IV. Okay, so for each of the dosage rates you see here, right, either the 2 milliunits per minute, which is the initial dose, okay, the 1.5 milliunits per minute, which is the incremental dose, all right, and then the 8 milliunits per minute, which is the maximum dose, right? Each of these dosage rates has a corresponding flow rate setting on the IV. Okay, and keep in mind that the strength of the solution is 20 milliunits per milliliter. Okay, so once again, this is the initial dose rate, the incremental dose rate, and then the maximum dose rate. Okay, so part A says calculate the initial pump setting in milliliters per hour. Okay, so the initial rate at which the patient is receiving the drug is 2 milliunits per minute. Okay, so that's where we're going to start. So 2 milliunits per minute. Okay, we need to convert that into a setting on the pump into milliliters per hour. Okay. Okay, so we're going to be using the strength here. Okay, so we're going to flip that over. Okay, so we're going to start by multiplying the initial dose of 2 milliunits per minute. All right, and we're going to multiply that by 1 milliliter over 20 milliunits. Okay, so the units of milliunits. Okay, so the milliunits cancel. Okay, and what we have, okay, is the flow rate of the IV in milliliters per minute. Okay, but what we want in the end is milliliters per hour. Okay, so 2 times 1 divided by 20. Okay, multiplying by 1 has no effect, so we're going to do 2 divided by 20 to get 0.1. Okay, so the flow rate on the IV in milliliters per minute is 0.1. Okay, so we're not quite there yet with the final answer. Okay, so 0.1 milliliters per minute. All right, so to convert this into a flow rate in milliliters per hour, right, all we got to do is multiply by 60. Okay, multiply by 60 minutes over 1 hour. Okay, so the units of minutes are canceled. All right, and then we should have our desired flow rate in milliliters per hour. So basically, okay, we're going to do 0.1 times 60, and that's it. And there's no need to divide by the 1 here, because dividing by 1 has no effect. Okay, so 0.1 times 60, okay, is equal to 6. Okay, so the initial flow rate on the IV is 6 milliliters per hour. Okay, so in order for the patient to receive the initial dose of 2 milliunits per minute, okay, the setting on the pump must be 6 milliliters per hour. Okay, so in part B, we're going to construct the titration table for this order. Okay, so it's going to include the initial dose rate along with the initial flow rate. Okay, and then the maximum dose rate along with the maximum flow rate, and then for every dose and flow rate in between. Okay. Okay, so to fill out the remaining part of the table, okay, we're going to take the 1.5 milliunits per minute, all right, and convert that into a flow rate in milliliters per hour. Okay, so it's a very similar calculation that we did here. Okay, so 1.5 milliunits, okay, per minute. Okay, that's the incremental dose rate. So in other words, if the desired response, in this case, which is labor, is not induced, okay, the directions say to increase the drug rate or dose rate by 1.5 milliunits, right, every 15 minutes, okay, until the patient goes into labor. Okay, so we need to figure out the corresponding incremental flow rate on the IV. Okay, so again, it's the same type of calculation. Okay, we're going to multiply by the 1 milliliter over 20 milliunits. Okay, so that we cancel out the milliunits. Okay, so you're going to punch that in your calculator. So 1.5 divided by 20. Okay, so it's 0.075. So do not round that decimal. So 0.075 milliliters per minute. Okay. All right, and we need that to be in milliliters per hour. Okay, so we're going to multiply by 60 minutes over 1 hour, like we did in the previous example. Okay, to eliminate the units of minutes. Okay, so on your calculator, you're going to punch in 0.075 times 60. Okay, so that's equal to 4.5 milliliters per hour. Okay, so this is the incremental flow rate for the IV. Okay, so in other words, if labor is not induced, okay, then you would increase the pump setting by 4.5 milliliters per hour, okay, until the patient goes into labor, okay, or until you reach the maximum dose rate. Okay, so now that we have the incremental flow rate, now we're going to fill out the rest of the table. Okay, so in the problem it said we're to increase the dose rate by 1.5 milliunits. Okay, so to fill out the left-hand side, okay, we're going to add 1.5 to 2 each time. Okay, so 2 plus 1.5 is equal to 3.5. Okay, so that would be the next dosage rate the patient would receive, okay, if labor is not induced. Okay, likewise, we're going to add 1.5 again. Okay, and we get 5. Alright, so on and so forth. Alright, until we reach the maximum dosage rate of 8 milliunits per minute. Okay, so 5 plus 1.5, you can check, is 6.5, then 6.5 plus 5, or 6.5 plus 1.5 is 8. Okay, so we're going to stop the table there, because that's the maximum dosage rate. Okay, so remember that the units of the dose rate is milliunits per minute. So let me go ahead and enter the units here for the maximum dose. So 8 mu, milliunits per minute. Okay, we don't go beyond the maximum dose rate. We stop there. Okay, so that's how we get the left-hand side of the table, which is the dosage rate. All right, so we already have the initial flow rate on the IV. Okay, and we figured out the incremental flow rate. Okay, in part B. So now we're going to fill out the right-hand side of the table. So we're going to take 6 and then add 4.5 to it. So 6 plus 4.5 is equal to 10.5. Okay. So again, if labor is not induced, right, to go up to the next dosage rate, we would increase the flow rate to 10.5. Okay, likewise, we're going to add 4.5 again. Okay, so the next setting on the pump would be 15 milliliters per hour. Okay, and then we're going to add 4.5 again. Okay, so the setting after that would be 19.5 milliliters per hour. Okay, and then lastly, the maximum setting on the pump, okay, would be 24. Okay, and we're not going to go beyond that. Okay, so that would be 24 milliliters per hour would be the maximum setting. Okay, so that's how we do the titration table. Okay, so you can fill in the left-hand side just based on the information given in the problem, right? So you start the table at 2 milliunits per minute, and then add the incremental dose, right, until you reach the maximum dose rate. Okay, and then you perform the necessary calculations to calculate the initial pump setting, which goes here. And then you take the incremental dose rate and then convert it into the corresponding flow rate, like we did here. And then you add that until you reach the maximum dose rate. Okay, so for each given dosage rate, you have the corresponding setting on the pump. Okay, so as you change the setting on the pump, that changes the rate at which the patient is receiving the drug. And the goal is to get the desired response, in this case to induce labor in the patient. So you adjust the flow rate accordingly, right, until labor is induced, or until you reach the maximum dose rate.